This is a video slide on conducting a simple regression and reviewing the literature. Linear regression is our topic. Our agenda: how to interpret a 95% confidence interval as an interval with a 95% probability of containing the population mean. Important facts: what is a simple linear regression? What is the R-square? Statistic and some of its limitations involved. First hypothesis test, debt to income. The second hypothesis test, savings to income. Third hypothesis test, stocks to savings. And important takeaways. Important facts. R squared is a statistical measurement of how close the data are to the fitted regression line. The linear regression will calculate an equation that minimizes the distance between the fitted line and all of the data points. How to use sample data to assess the or reject the null hypothesis. The test procedure consists of 4 steps. 1, state the null hypothesis. 2, formulate an analysis plan. 3, analyze sample data. And 4, interpret the results. The first hypothesis test for regression: no significant results found. The following regression was conducted. The null hypothesis stated that the slope of regression coefficient b, beta, is 0. The alternative hypothesis stated the slope of regression coefficient beta is non-zero. A simple linear regression was conducted to determine whether debt could be predicted from income. Debt could not be predicted using income because no significant regression was found. Beta equal minus 0.5, R squared equals 0, and p-value was 0.535. The p-value failed to reject the null hypothesis and significant findings for regression. The second hypothesis test for regression: a significant result found. The following regression was conducted. The HO, the slope of regression coefficient beta, is 0. The HA, the slope of regression coefficient beta, is non-zero. A simple linear regression was conducted to determine whether savings could be predicted from income. A statistical significant regression emerged. Beta equal minus 0.91. The R squared was 0.82, and the p-value equals 0. Thus, the test rejected the null hypothesis and a prediction that savings could be predicted using income because significant regression was found. The p-value rejected the null hypothesis, a significant finding for regression at the 95% confidential interval at 0.9 and 0.11 does not contain 0, hence lending support to the prediction. A third hypothesis test for regression: a significant result found. The following regression was conducted. The HO, the slope of regression coefficient beta, equal 0. The slope of regression coefficient beta is non-zero. A simple linear regression was conducted to determine whether stocks could be predicted from savings. A statistical significant regression emerged. Beta equal minus 0.28, R squared equal 0.07, and p-value is 0. Thus, the test rejected the null hypothesis and predicted that stocks could be predicted from savings because a significant regression was found. The p-value rejected the null hypothesis because a significant finding for regression at the 95% confident interval of 0.7 and 0.25 does not contain 0, hence lending support to the prediction. Important takeaways: Remember that the PSPP can run your statistical data for linear regression, that the null hypothesis states the slope is equal to 0, that the alternative hypothesis stated that the slope is non-zero. Remember that comparing the p-value to the significant level and rejecting a null when the p-value is less than significant value. Two variables are dependent and independent for the simple linear regression test. The annotated bibliography supports the connotations found in our data report. Thank you for watching. Do you have any questions?